And welcome to Unit 11 Probability Part 2. Today we're going to be learning about permutations and combinations, and they're going to seem a bit confusing at first. Just re-watch the video if needed, and note that it's just going to take some time to mull this over because it's new information, all right? So take notes as you go so that you have some examples to refer back to and just do your best. So you're going to learn a new symbol, which is the exclamation point. You're also going to learn what the difference between a permutation and combination is, and then you're going to be able to calculate them both by hand and with your calculator. So the first thing we're going to learn is what that factorial means. So it is just a math symbol. It's the exclamation point, but in math, it means that you just multiply all the numbers all the way down to 1. So 4 factorial will be 4 times 3 times 2 times 1. So you just multiply that. That's 12, 24. 8 factorial would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So again, that exclamation point means you just multiply all the numbers from that all the way down to 1. And sometimes these are going to get big, so you're going to need to use your calculator. So I'm going to show you two ways. One way is to just literally do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we get 40,320. Another option is to go to math on your calculator. So you're going to type in 8. I'm going to go to math. I'm going to go over to PRB or prob, depending on what calculator you have. And it's number 4. You're just going to hit enter, and it's going to calculate the same number. It's just not going to need to write it out. All right, so now let's look at trying these next ones by hand because something is going to happen. So 7 factorial is 7, 6, 5, 4, 3, 2, 1. I don't know why. Hold on. I don't know why I'm using the X for multiply. It's easier to use the dot. All right, 3 factorial is 3, 2, 1. What you're going to notice when you have it is you can always cancel some. So we can cancel anything below 3. So really all we're doing is 7 times 6 times 5 times 4. So we get 840 for this first one. Now the next one's going to be even easier because 5 factorial is 5, 4, 3, 2, 1. 4 factorial is 4, 3, 2, 1. So anything 4 and below can be canceled, so we just get 5. And that's important to note because that's what we're going to use to calculate combinations and permutations by hand. All right, so we can use factorial now to solve this. This is saying how many ways are there for 5 students to line up. So I first like to visualize. I have spot 1, 2, 3, 4, and 5. So for that first slot, I have 5 options. But once that person is in the first slot, I only have 4 options for the second slot, 3 options, 2 options, and that last person is stuck at the end. That's a factorial. That's the same thing as 5 factorial or exclamation point. And again, I could remember how to use my calculator to do that. I can type in 5 math over to prob down to number 4, and it will calculate it for me. 5 factorial is 120. You could also multiply 5, 4, 3, 2, 1 in your calculator if you don't have a calculator that has that button. All right, so that's factorial. Here's another example of factorial again. A lot of times factorial will be lining up, ordering something. So I have 16 people. I want to know how many ways there are for 16 people to line up. Again, I could draw it out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now that's a lot of work to write 16, 15, 14. So an easier way is to just write 16 exclamation point. And I'm going to use my calculator to do this one, 16 math. And there's going to be a lot of ways because it's a lot of numbers multiplying. So 16 factorial gives me that e to the 13 means there are 13 times you have to move the decimal over. So if it's 2.09 times 10 to the 13th, that means you take the 2.09, you write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's a ginormous, ginormous number. What you really notice is that once you get factorials that are above like 8, 9, they're going to be very large numbers. So sometimes we're going to restrict them. So we might change the problem to be how many different ways of the 16 people can they choose a president, a vice president, and a secretary? Now, order matters on this one because if I want to be president, I don't want to get the secretary role. So let's say we got John, Abdullahi, and Isaac. Oh, that seems weird. I need a girl in there. Let's do John, Abdullahi, and we'll do Muna. All right, so that gives me 3 different letters. John, Abdullahi, Muna. All right, so John could be the president, Abdullahi could be the vice president, and Muna could be the secretary. Or a different way would be Muna to be the president, Abdullahi to be the vice president, and John to be the secretary. So the order matters for these, all right? So I have 16 people to choose from, and I have 3 spots. So 1, 2, 3. So I could choose 16 different people to be the president. But once I put one person in the president, I only have 15 people left to choose from to be the vice president, and I only have 14 people left to choose from to be the secretary. So this isn't 16 factorial, it's 16 times 15 times 14 because we only have 3 spots. So I'm going to do 16 times 15 times 14. And that gives me 3,360 different ways to choose a president, vice president, and secretary from 16 different people. So I had 16 people to choose from. I was only picking 3 positions, but the order matters because I wanted to pick 3 different positions: the president, the vice president, and the secretary. Right? So this is called a permutation. So this is going to be something else you want to write in your notes. So a permutation, the big thing is that order is important. So examples would be like first, second, third place in a race, picking a president, vice president, secretary, lining people up on stage. Numbers cannot repeat, so you can't get first and third. You can only get first place. You can only get third place. You can only be the president. You can't be the president and the vice president, all right? So permutation, the big thing is order matters. Whenever they're talking about order, that's a permutation, right? So here's what you want to write down for permutation. It's a big letter P. This is the notation for permutation. N is the number of things you're choosing from. So for example, we were choosing from 16 people, and we only chose 3 positions. So N is the number you're choosing from. 3 is how many positions or things you are actually choosing, all right? So the by hand way to solve that is it's the total number divided by the number minus how many you're choosing factorial. So remember that exclamation point means factorial. So let's go back to this example and use that definition to calculate our permutation. So 16 people, I'm choosing 3 positions. So if I wanted to calculate 16p3, I would do 16 factorial over 16 minus 3 factorial, which is really 16 factorial over 13 factorial. Now remember back to this slide when we were learning how to simplify those? Everything's going to cancel beyond that bottom number. So if I go to calculate this now, I'm going to write out 16, 15, 14. But then 13 and below is going to cancel because the bottom is 13. So 13, 12, 11 all the way down is going to cancel. And I would still just get 16, 15, 14, which I got was 3,360, I believe, right? 16, 15, 14. So I get the same answer. So you can either use the P button or the notation of P, 16P3, or you can just think there are 3 spots. I'm going to write it out 16, 15, 14. But note that it's called a permutation because the order matters, all right? So now we're going to look at another example here and see what's different. So Diversity Club is selecting judges now for their show. They have 16 people and they need 3 judges. So I want you to think about, like, you know, your American Idol, your dance competitions. It doesn't matter what order the judges are in. It doesn't matter where they're sitting. It just matters that there are 3 people to be judges. They have equal positions. So the order doesn't matter. Let's go back to my John, Abdullahi, and Muna. If I pick those 3 people, reordering them to Abdullahi, John, and Muna, those are the same thing for these judges. It doesn't matter what order they sit in. So I can't change up the order. I've still chosen the same 3 people here. All right. don't know why I crossed that out. So this is different than a permutation. This is called a combination, all right? So combinations are a little bit more complex than permutations because I can't just do this. I can't just say 16, 15, 14 because I'm not ordering them. I'm going to have repeats then. So combinations are smaller than permutations because, again, if I go back to my John Abdullahi Muna, switching it up to this order means the same thing for a combination. So I can't just flip them around and say that's a new thing. They're the same things, all right? So combination, this is the next thing you're going to write down. Order is not important. You're not lining people up. You're not ordering. You are just selecting people or selecting toppings for your pizza, or it doesn't matter what order things go on. It just matters that you're picking those three things, all right? Same thing true though, numbers cannot repeat. Each thing needs to be unique. So here is the notation for a combination. It's NCR, same thing as a permutation. N is the number of things you're choosing from. R is the total number of things you choose. So the notation for the last one we did would be 16 combination 3. All right, and then the last thing is this is the notation for a combination. So if we look at it, it looks the same as a permutation. Let's look back at permutation. It's n factorial over n minus r factorial. So the combination is n factorial over n minus r factorial, but they have this extra r factorial, which is the 3. That's dividing out the repeats because order doesn't matter, so it's dividing by all the different orders we did so that it's going to be smaller. It's going to take away all of those repeated things like AMJ versus JM. Okay? All right, so let's try to calculate this one by hand using the notation. So if I have 16 people, right? So I have 16 C3 now instead of P. So I'm going to start the same. It's going to be 16 factorial over 16 minus 3 factorial. The difference is, oh, I don't want that factorial on the inside. Hold on. The difference is now I have to also divide by 3 factorial, which is my r. All right, so I get 16 factorial over 13 factorial and 3 factorial. So this one's a little bit different. Same thing is true. 16, 15, 14, 13. Everything below 13 is going to cancel. So I'm going to cancel this out and this out. But I still have the 3 factorial on the bottom. So it's 16, 15, 14 over 3, 2, 1. Just going to calculate that. 16, 15, 14, remember, is 3360. 3 times 2 times 1 is 6. So I'm just going to calculate 3360 divided by 6. And there's only 560 different ways for me to do a combination versus the permutation was 3,360. So combinations are smaller because you always have this extra r factorial. You are dividing out the repeats, right? Now I know this seems confusing at first, but follow the rule, follow the equation, okay? We're going to practice just doing some without the words and just practice our multiplying by hand, and then I'm going to show you the button on the calculator you can use, okay? All right, so let's remember our permutations. Permutations is, so if it's NPR, it's n factorial over n minus r factorial. If it's NCR, it's n factorial over n minus r factorial. And then remember, we have to divide out the repeats of that r factorial. All right, so go ahead and pause the video and see if you can just write out what these would look like. If you can't calculate them, that's fine. If you can, go ahead. All right, so this N10P5 is going to be 10 factorial over 10 minus 5 factorial, which gives me 10 factorial over 5 factorial. If you got there, that's great. If you made it further, you should have written 10, 9, 8, 7, 6, and stopped at 5 because everything below 5 is going to cancel. So we got 10 times 9 times 8 times 7 times 6. So I'm going to calculate that. 10 times 9 times 8 times 7 times 6. And I get 30,240. So again, permutations are usually large numbers, right? So go ahead and try 52p5 now. The p's are a little easier than the c's. Go ahead and try the permutation. All right, so this would look like 52 factorial over 52 minus 5 factorial. So we would get, oh, my marker's not working. 50, ignore that. 52 factorial over 53 not 53, oh my gosh. 48, 47 factorial. 52 minus 5, let's just double check my terrible math here. It should be 47, not 53. All right, so 47 factorial. So remember, it's going to be 52, 51, 50, 49, 48, 47, and anything below that is going to cancel. So I'm going to cancel that out, and I'm just going to multiply 52 times 51 times 50. This one's going to be huge. All right, and we get 3,118,75200. So that is 311,875,200. All right, so now the the combinations are going to be smaller because we have to do that extra division step. So go ahead and pause it and see if you can write out the combination notation. So this is going to be 10 factorial over 10 minus 5 factorial over 5 factorial. All right, so it's going to be 10 factorial over 5 factorial, 5 factorial. All right, so I get 10 times 9 times 8 times 7 times 6. Everything below 5 is going to cancel, but I can only cancel out one of them. So I really get 5 times 4 times 3 times 2 times 1. So I'm just going to calculate that. The top part we already calculated on the permutation, which was 30,240. We just have to do 5, 4, 3, 2, 1. And we get 120. And then we divide them. 30,240 divided by 120 gives me 252, so much smaller than the permutation for that. Okay. All right, and the last one of this type is going to be 52 factorial over 47 factorial, which is the same as the permutation, but then we have that extra 5 factorial. All right. So if we look over here, it's the same as the permutation, so it's going to be this big number, 311,875,200 over 5, 4, 3, 2, 1, because the 47 is going to cancel, right? So we're going to do that number divided by 120. And that gives me a much smaller number of 25, oh, I turned it too quick, 98960. So if you notice, that's a much smaller number than the permutation example of that, right? All right, so the last two I'm just going to walk through. We're not going to do them since now you know how to do them by hand. I'll show you how to use the calculator. So I just want you to first identify whether it's a permutation or a combination. So in a club of 30 members, how many ways can we form a committee of 6? So that would be a combination because I'm not selecting position, so it'd be 30C6. The second gives you a little bit more detail. It says how many are there if a president needs to be on the club. So that means I have 30 members. One member must be the president. So I'm down to just having 29 to pick. I'm assuming that I'm assigning that one person already. So it's actually 29C5 because I've already taken away one from each of these by assigning the president. So I took away one because I only have 29 people. I'm automatically assigning the president. I'm only picking 5 more members because I've already assigned that one member, which is the president on the committee. All right. What if I want to change it to being a president, vice president, and secretary? So that would actually be a permutation. So it'd be 30P3. All right. So I have 30 people to choose from, and I'm choosing 3 people to be in positions. So that would be an example of a permutation. All right, and lastly, cherry berry offers 35 different toppings. Miss Linsky wants to put 3 toppings on her yogurt. This one, some people like to argue, but really, your yogurt's all going to get mixed together, so the order doesn't matter. So this would be a combination, so it'd be 35C3. Same type of thing as the president. How many ways can she do this if she already wants hot fudge? So again, that means she only has 34 toppings to choose from, and she's only picking 2 more toppings because the hot fudge is automatically on it. All right. The last thing I'm going to show you is just where the buttons are on your calculator. So it's actually in the math button. So let's say I wanted to calculate 35C3 with my calculator. I'm going to type 35, math, over to prob, and the P is the second one, the C is the third one, so I'm going to do 35C3. And you have to type the 3 after you hit enter on it, and we can get our answer without having to do it by hand. So you have 2 different options. You can use the button. Again, it's under math. And then scroll over to PRB or prob. And there's the P, the C, and the exclamation point. All right. All right, so go ahead and do your best on your assignment today. I will be back tomorrow to help you recap everything. So do your best, please. Make sure you've tried it so that you're not missing out because I'm not going to be able to do everything in one day. I know this was long, but it's meant to help you get ahead of the game so that when I come back, I can help you get everything cleared up. Have a wonderful day. See you tomorrow.